Hey guys, so I always get excited when they finally release the test and I get to see what it is that you saw when you took it. Or for those of you that didn't take it or just kind of curious what you missed out on, here is the first question off of this year's AP test. So let's pull that up here. It says they've got the density of a bacteria. Now, density is kind of an important thing. It's like your volume, like how much of you have distributed over a volume. So the density of some bacteria population in a petri dish at a distance r from the center. So notice as you move away from the center of the petri dish, it, interestingly enough, seems to become more dense or more bacteria in there. It's an increasing differentiable function. That's kind of an important thing. Now that word differentiable means, remember, it's the derivative exists everywhere in the domain, and the differentiability implies continuity. That's going to show up in this test a few places, where f of r is measured in milligrams, like the quantity you have per square centimeter. Okay, so the values of f of r are given in the table, and now we're supposed to use that to estimate 2.25. And you'll notice up here we don't have 2.25, but we do have two values that surround 2.25. So we've certainly done something very, very much like that in class. So f prime of 2.25 is going to be approximately, now keep in mind it's not going to be exact, so it's going to be right in here, it's going to be 10 minus 6 over 2.5 minus 2. We're talking 4 over 1/2, or in other words, 8. Fairly nice, easy set of numbers. We can have a calculator, but I don't think we really need one for that kind of stuff. And of course, these things are milligrams per square milligrams per centimeter squared, and that was divided by centimeters, which again, that's interesting because that's centimeters squared, and but this centimeter is in measurement of how far from the center it is. And so what that actually means is at 2.25, the density is increasing at approximately 8 square centimeters, 8 milligrams per square centimeter as you move from the center. So anyway, good enough. There we go. For part B, they did something that's a little bit interesting because you have to be really, really careful here that this is f of r right here, and this is f of r, but the boogers did something a little tricky. They didn't ask us to integrate f of r, they asked us to integrate r times f of r. So we could modify this table up here and write r times f of r up here because, well, they're kind of adding a little piece to it. So r times f of r would be 0. R times f of r would be 2. This is 12, 25, and 72. That was a little bit of a harsh little thing to do. And so now if we are going to say for part B that we have 2 pi integrals from 0 to 4 of r times f of r dr, would be approximately, keep in mind, we're just going to leave that 2 pi sitting out in front because it's a constant, but then we're supposed to do a right side Riemann sum, which means we're supposed to take the value, I'm going to slide this back up here, the value 2 multiplied by the interval width 1 plus the value 12 times the interval 1 plus the value 25 times its interval right here, which was only 1/2, and 72 over here multiplied by its interval 1/2. So that's looking pretty good. Now, we still have this 2 pi sitting out in front, but this is the calculator active section, so we're just going to go ahead and multiply that out, and you get 845.088. Now, again, what we'd like to do is put in what those units are. So what's a little strange about that is if you look at it and you track that, this was milligrams per square centimeter multiplied by centimeters, and then multiplied by centimeters again. And so it turns out this just becomes milligrams. Because if you take the square centimeter in the bottom, multiply it by another square centimeter for FR, but then when you multiply it by R itself, we lose another centimeter, and you just get milligrams. I get how much of that stuff, regardless of distance from the center, that's just how much of that medication is in the system. So for part C, they're asking if it's increasing, or if it's an overestimate or an underestimate. So the thing is what we want to talk about is the integral of 2 pi times r times f of r dr. Now it's not f of r itself, but since r and f of r are known to be increasing functions, then r times f of r is also an increasing function. So a right side Riemann sum. So I usually draw a picture, think about some kind of an increasing function and make our right Riemann sum. It doesn't take very long to just sort of demonstrate, oh yeah, that's right. That's going to be is an overestimate. Okay, good to go. Now, part D is one of those problems that they threw a buzzword in here. They're like, oh man, there it is, the word average. So kind of interesting. They're saying the density of the particle is modeled by this function. Instead of the data, we can actually now talk about this. So what value of g of k is the average value on that interval? So what they're saying is g of k, I want to find out what value of that works. Now our formula is 1/4 minus 1, integral from 1 to 4 of g of r dr. Now, of course, keeping in mind that this is a calculator active session, I'm not going to do anything super duper fancy. I'm literally just going to take the function that they gave me, and I'm going to ask it to integrate that function from 1 to 4 and multiply it by 1/3. So I just poked it in. Now, when I did that, I got 9.8779. And the question is, when is g of k equal to 9.8779? Now, I stored this value. And let's go ahead and do that thing. So I've got my function in here. Let me make sure that I'm in radians, because there's definitely a little piece in there talking about some trig. So we had 2 minus 16 parentheses, and we got to be really careful because they added some parentheses to this problem, which could definitely get us into hot water. 157 square roots of r, and my calculator does not have pretty print, so I have to be very, very careful about my parentheses. I opened this, I opened, so I need 3 closes to get all the way to here, and this whole thing is supposed to be cubed, and I needed to take the integral of function y1, comma x, comma 1, comma 4. Said comma 4, but I didn't do it. And then, of course, divided by 3. Now, I'm going to store that as a, because I wanted to have that value. And so what they wanted to know is, when is this number equal to the average of that? So what I'm going to do is I'm going to tell this to be a, that average value. Now, I don't really totally know too much about this function, but again, if you take anything that is a cosine of any kind, and so again, looking back at this thing right here, cosines alternate up and down between 1 and -1. So the biggest that this could ever be is 1. So we could be 2 minus 16 or maybe 2 plus 16. So that value, as far as a window goes, we're only interested in 1 to 4. And I just gave it a little bit of a range up and down. Starting at 2, I went up 16 and down 16, and then I just broadened it a little teeny bit. So here comes the original function. That's g of k, or g of r. Here comes that average value that I desire, and I can calculate that intersection, ding, ding, ding. And it appears that for the value of k that would actually make that work was 2.497. And that is question number 1 from the 2021 released AP test. Awesome. I'll see you for number 2 in a little bit.